Bismillahirrahmanirrahim.
In the previous video, we have discussed what is normality. We have also discussed the formulas of normality. I have also discussed, for preparation of normal solution of any solid substances, just follow 3 steps. Step 1. Find the equivalent mass of substance. Step 2. Multiply the equivalent mass by required normality. Step 3. Take the coming mass of substance, dissolve it in water, and dilute the solution up to 1000 milliliters. This will be normal solution of a substance which is in solid form. I have also explained how we can find equivalent mass of a metal, ion, salt, acid, base, and oxidizing or reducing agents. Let's have a quick look on it. For calculating equivalent mass of metal, divide atomic weight of metal by its valency. For example, for calculating equivalent mass of sodium, divide 23, which is the atomic weight of sodium, by its valency, which is 1. So the equivalent mass of sodium is 23 grams. For calculating equivalent mass of an ion, divide weight of ion by its charge. For example, for finding equivalent mass of sodium ion, divide 23 by 1. So the equivalent mass of sodium ion is 23 grams. For finding equivalent mass of chloride ion, divide 35.5 by 1. So the equivalent mass of chloride ion is 35.5 grams. For calculating equivalent mass of salt, find the equivalent masses of both cation and anion. Then add the equivalent mass of both cation and anion. For calculating equivalent mass of sodium chloride, firstly find out equivalent mass of sodium ion and chloride ion individually, which is 23 for sodium ion and 35.5 for chloride ion. Now add equivalent masses of sodium and chloride ion. The required equivalent mass of sodium chloride is 58.5 grams. For calculating equivalent mass of acid, divide molecular weight of acid by its basicity, where basicity is the number of replaceable hydrogen ions in any acid. For calculating equivalent mass of phosphoric acid, divide molecular weight of phosphoric acid by 3. As 3 is the number of replaceable hydrogen ions in phosphoric acid. For finding equivalent mass of a base, divide molecular weight of base with its acidity, where acidity is the number of replaceable hydroxide ions in any base. For example, to calculate equivalent mass of sodium hydroxide, divide 40 by 1. As 40 is molecular weight of sodium hydroxide and 1 is the number of replaceable hydroxide ions in it. So equivalent mass of sodium hydroxide is 40 grams. For finding equivalent mass of oxidizing and reducing agents, divide molecular weight of oxidizing or reducing agent by number of electrons loss or gain. For finding number of electrons loss or gain, write the balance chemical reaction involving oxidation or reduction. Find out the oxidation state of oxidizing or reducing agent in both reactant and product. And find out the difference between the two state. For example, for calculating equivalent mass of potassium permanganate, find out total number of electrons gained by manganese in the reaction. As manganese has +7 oxidation state in reactant, and +2 oxidation state in product, so the number of electrons gained by manganese in the reaction is 5. Now divide 158.03 with 5. To get equivalent mass of potassium permanganate, which is 31.6 grams. In this video we will learn in detail with examples the preparation of normal solution of ions. To prepare normal solution of any ion, always follow these 3 steps. First of all, find out the equivalent mass of ion. As I mentioned earlier, for finding equivalent mass of ion, just divide mass of ion with its charge. Then, multiply the equivalent mass by required normality. Take the coming mass of ion, dissolve it in water and dilute the solution up to 1000 milliliters. Let's discuss the preparation of one normal solution of chloride ion using sodium chloride salt. Let's do the calculations first. Find out equivalent mass of chloride ion. Always remember, if you want to find out weight of ion from salt, divide mass of salt by weight of ion. So here we divide 58.5 by 35.5, which gives 1.65 grams, which is the weight of chloride ion in sodium chloride. For calculating equivalent mass, divide 1.65 by 1. As mass of chloride ion in sodium chloride is 1.65 and charge on chloride ion is 1. Then, multiply 1.65 by required normality, which is 1. The answer is 1.65 grams. Take 1.65 grams of sodium chloride in beaker. Dissolve it in water and dilute the solution up to 1000 ml. For performing the experiment, the apparatus required are empty dry beaker, distilled water, sodium chloride, spatula, stirrer, measuring cylinder, 1000 milliliters measuring flask, filter paper, and funnel. First of all, turn the weight balance on. Now place the empty beaker on the weight balance. The weight balance display its weight. Now press the tare button. You can see that weight balance shows the weight of beaker as 0. Take 1.65 grams of sodium chloride in beaker. With the help of spatula, add some water into measuring cylinder. Now add it into the beaker having 1.65 gram of sodium chloride. Stir the solution with the help of spatula. Continue stirring till all sodium chloride dissolve completely in water. Open the flask. Place the filter paper on funnel. Always use filter paper, as it removes any kind of impurities if present in solution. Now add the sodium chloride solution in measuring flask. Add more water up to the mark. Store the solution for further use. This is one normal solution of chloride ion. To prepare 2 normal solution of sulfate ion using magnesium sulfate. First of all, find the equivalent mass of sulfate ion by dividing 1.25 by 2. As 1.25 is the mass of sulfate ion in magnesium sulfate and 2 is the charge on it. Now multiply 0.625 with 2. As we want to prepare 2 normal solution. So the answer is 1.25 grams. Take 1.25 grams of magnesium sulfate. Dissolve it in water. And dilute the solution up to 1000 milliliters. This will be 2 normal solution of sulfate ion. To prepare 1.5 normal solution of carbonate ion using calcium carbonate. First of all, find the equivalent mass of carbonate ion. Then divide 1.67 by 2. As 2 is the charge on carbonate ion and 1.67 is the weight of carbonate ion in calcium carbonate. Now multiply 0.835 with 1.5. As we want to prepare 1.5 normal solution. So the answer is 1.25 grams. Take 1.25 grams of calcium carbonate. Dissolve it in water. And dilute the solution up to 1000 milliliters. This will be 1.5 normal solution of carbonate ion. To prepare 0.5 normal solution of potassium ion using potassium chloride. First of all, find the equivalent mass of potassium ion. For this, divide 1.91 by 1. As 1 is the charge on potassium ion and 1.91 is the weight of potassium ion in potassium chloride. Now multiply 1.91 with 0.5. As we want to prepare 0.5 normal solution. So the answer is 0.95 grams. Take 0.95 grams of potassium chloride. Dissolve it in water. And dilute the solution up to 1000 milliliters. This will be 0.5 normal solution of potassium ion. So you can prepare normal solution of any ion by performing these 3 steps. Let's recall them. First of all, find out equivalent mass of ion. By dividing atomic weight of ion with its charge. Then multiply equivalent mass with required normality. And at the end take the coming mass of ion in beaker. Dissolve it in water and dilute the solution up to 1000 milliliters. After seeing this video, you can now prepare normal solution of any kind of ion. In the next video I will discuss how we can prepare normal solution of salt. With some examples. Till then, like, share, and subscribe to my channel. Thank you.